And folk, we don't know this because there's no good IPv6 traffic test equipment. So we can't test the vendor's assertions that everything is wonderful. All vendors are not spinning the ASICs to solve this, the hardware. And all v4 features are not supported in v6, like MIBs, SNMP, etc., etc. Another myth is there's no static numbering. Everything auto-configures. It's wonderful. But the problem is that enterprise security, within enterprises, all the security concerns, etc., mean they statically number, just like they always did v4. And the ISPs, for all our backbones and for all our routers, want static numbering. So the dynamic auto-configuration works very nicely in the home environment and other small environments. It's not selling too well in the larger environments. There's another myth that IPv6 is deployed widely. There are pioneers succeeding. I noted this morning that this network is provisioned in IPv6 and works quite well. I made it all the way home over v6. Early adopters are just getting seriously in the game. Actual measured traffic is very small. So it makes routers look good at least. Okay, but there are success stories. There are success stories. But just to give you an idea, this is address space allocations from the registries. Afrinic, LACNIC, you know, here's RIPE, the European region. Here's APNIC, misspelled. APANIC, that's very good. This graph was done by a graduate student, sorry, etc. Notice those nice big uptake of IPv6 if you look at how the registries are allocating. Now let's look at the BGP protocol and see what's being actually announced on the internet and utilized. Not a pretty picture, is it? They started to go flat in about 2004. So all those addresses in the RIPE region that were being given to by the registry, nobody's using them. So don't look at registry data when we talk about how successful IPv6 is. IPv6 is ubiquitous in Japan. I live in Tokyo. Okay? The two big providers do have dual stack on leased line services, but they don't have it over the common service, which is ether to the home, which really means ether to the basement of your apartment building and 100 base up. And I have a real usable 100 megabits in and out from my apartment for the equivalent of about 25 euros a month. Eat your heart out. Neither provide native or dual stack over the standard service. There is a closed v6 service. It's not a v6 service. It's how they implement VoIP and some television, not really internet. IPv6 will replace v4, not given the current lack of universal vendor support. It's far easier to use NAT, and this is horrible, and this is something we will regret for the rest of our lives. The problem is, right now, it makes more financial sense in your operation. Okay? So the reality, as Garab says, is 96 more bits, no magic. But we need those bits badly, okay, because we are running out of v4. The key question is how to use them, how to transition without losing anybody. And the way is to make v6 easier to deploy. How do we do that? We identify the problems. We don't make believe it's wonderful and cures your common cold. Right? We actually acknowledge and identify the problems. We see that they're fixed. We ask the IETF to fix any outstanding protocol issues. We ask the IETF to stop adding to it and trying to make it prettier to make it sell. We need it stable to deploy it. Okay? And we need to lean on the vendors very heavily for the tools. Oops, that was a very bad button. What we should not do is pretend there are no problems. What we should not do is try to market v6 by giving away IP space, because we're only going to complain about, MIT has more address space than China, which it never did. And we shouldn't make messes like v4 natting that we're going to have to live with forever. The areas of concern are many. That's essentially the stack. Layers 1 and 2, just for some examples, Docsis. Yeah, it's in Docsis 3.0, but their CMTS doesn't have support, and there's a massive install base of Docsis 2. People aren't going to throw that. Backbone engineering. The conversion to dual stack in the core is slow, but the routers can kind of do it, especially with the low traffic rates of v6. But you have to go all the way to your provisioning backend, to address assignment, to DNS, etc. All has to convert. And there's still the DHCP conversion. There's still monitoring and measurement. And guess what? You get to buy new Cisco line cards, but you have to do that every month anyway. Okay. There's the last kilometer problem, authentication and session setup, conversion to IP over Ether, provisioning and backend, and this is a very large cable carrier, Comcast, saying, how do I scale to millions of customers and wanting to move them on POPs and stuff? There is no $50 DSL modem to support v6. There is no $50 home firewall to support v6. The two proposals out of the IETF don't fly. Security devices. Dave Piscatello made a report for ICANN, IPv6 support among commercial firewalls. He actually tested the firewalls. He didn't read the marketing literature. He actually talked to people who own them. Less than 1/3 could move an IPv6 packet at all. 25% could route it. And the statistics, as you tested for functionality, got worse and worse. The enterprise, as I said, all the stuff has to handle it. PeopleSoft, Seabold, business applications, SAP, good folk at SAP. Firewalls, VPN, millions of lines of in-house code, NFS appliances, load balancers. Finally, F5, just 2 weeks ago, came out with a v6 capable load balancer, the first one. Applications. Where's the web page with a matrix of application by platform showing which are v6 capable and a clickable link to say how to configure it? Right? There was a startup of one. It's totally out of date. Many applications which support v6 have poor enough performance in v6 that they advise you to turn it off. Right? This is not the way to convert. SMTP is an interesting example. This is email. It's a mandatory application. I mean, we do want to be able to mail from a v4 site to a v6 site. We just do. Everyone needs to be able to do it. But due to spam, you can't run an open public relay because it will be abused within 32.4 seconds. Okay? So all v6 sites need to have the ability to SMTP to arbitrary v4 sites. Therefore, everybody needs a private dual stack relay. Part of what you're going to have to do to play in the game of the internet is a dual stack SMTP server. Why is Japan a little bit ahead? Because Murai Sensei years ago convinced the government that early movement was wise for the country. So the government supported IPv6 research with yen, not dollars, but it wouldn't work in the slide. Government supported IPv6 development by industry and vendors. And the government today gives tax incentives to enterprises, end users, who become v6 capable and compatible. What can we do? This is what Queen Lucy of ISOC says. No more bullshit. No more excuses. Spend the money. She was having a bad day. But if we don't, we're in trouble. A basic principle, one internet. We do not want a v4 and a v6 internet. Under no circumstances can we allow it to fragment. During the transition, everybody still needs to communicate with everybody else.